Ever heard of Terraform? Don't know how to use it? Thinking about all the possible applications of Terraform? Thinking what is infrastructure as a code? You have come to right place. I will help you understand these concepts. Not these, I make videos related to other DevOps methodologies as well as applications which are used in the industry. So please make sure you subscribe to the channel. So, Terraform is an open source tool. It is used to automate the deployment of infrastructure as well as manage the infrastructure. It is a declarative language which is used to deploy your platform as well as the services which are running on those platforms. Declarative meaning you don't have to define each and every step of the process. You just have to define the end result and Terraform will figure out how to execute those. As I mentioned, Terraform is used to deploy infrastructure. But what kind of infrastructure? Suppose you have a Node.js application or a web application. You will need some place to run those applications. You will need servers where Node.js is installed. Or if you are packaging your application in a Docker image, then you will make sure that server is able to run that Docker file. This infrastructure can be set up anywhere, but in this video we'll take an example of setting the infrastructure on a very popular cloud provider, AWS. But how does Terraform manages to deploy a infrastructure or resources on AWS? Before answering that, let's see what is an infrastructure as a code and how does Terraform is different from other IAC tools. Here IAC stands for Infrastructure as a Code. Let's go way back when DevOps tasks were not automated, where when you have created an application and wanted to deploy on a server, people need to set up the server, configure the networking, install the dependencies and manage the applications manually. These steps took more efforts and time to complete, and also human errors were involved, and it just not end with just deploying the infrastructure. There is managing and maintaining those infrastructure as well. Speaking of infrastructure, every application will be deployed to at least 3 infrastructure. Those are divided into dev environment, QA environment for testing as well as production. So infrastructure as a code helps us to automate these tasks end to end. Infrastructure as a code is a concept which has applications, programs and scripts which help us to achieve these tasks. There are multiple tools which are available today to help us with these tasks. These are Terraform, Ansible, Chef, Puppet and AWS native CloudFormation template. But none of these tools are capable of automating end-to-end. The tool which you would be using will depend on the requirement. Terraform can be used for initial infrastructure setup as well as managing those infrastructure, and we can use Terraform to set up the application initially. But Terraform cannot be used to manage the application, whereas Ansible can be used for initial application setup as well as managing that application. Ansible can also be used for managing already deployed infrastructure, but Ansible cannot deploy the infrastructure from scratch. Now, coming back to the question, how does Terraform manages to deploy the infrastructure onto a cloud? Here, you can see this is a Terraform file. .tf indicates this is a Terraform language. Terraform language is a rich language designed to be relatively easy for humans to read and write. This is in JSON syntax. Main thing to look into a Terraform file is the provider block. Providers are logical abstraction of an upstream API. These are responsible for understanding upstream API as well as exposing the resources. In general terms, they help you to communicate with the service provider and deploy your resources. So this Terraform file is for creating EC2 instance in AWS cloud. Hence, the provider block mentions the AWS provider. Next is the resource block, which defines the resources to be deployed. It comes with a syntax which mandatory defines the resource name and a custom user defined name for future reference. So the basic required value for creating an EC2 instance is the image value, that is the Amazon Machine Image AMI, or the instance type. You can choose to define these values directly in this file, or as per the standard, we can select a separate file to define these variables. Each variable is declared with a variable block. If none of the default value is provided, it will prompt for an input during runtime. Apart from these, there is one more block known as data source block. Data source allows the value to be computed or fetched for use elsewhere in the Terraform configuration files. Use of data source allows us to use a value or a data which is outside our Terraform configuration, or it can be defined somewhere else in a Terraform configuration file and then we can use it. It is simply referred to as you are fetching a data or a metadata from the cloud provider direct during the runtime and using that value to pass as a variable to some other block. So after defining all these blocks, our Terraform script is ready. Initialize this Terraform script right into the same directory where we have declared the Terraform file. So Terraform init will compile all the files in the directory having the extension with .tf. This will also download the provider for you. After running Terraform init, you can see there is a directory with .terraform created. After the initialization is complete, you can run Terraform plan, which will create an execution plan for you. The plan command itself won't execute the changes which you have proposed. This will just create an execution plan so that you can match this execution plan with your requirement and make sure the changes which the Terraform is going to do is based on your requirement. You can also share these changes across your team for broader reviews. If you are using Terraform directly in the interactive terminal, then to apply these changes, you can run Terraform apply command. By default, the Terraform apply will automatically create an execution plan for you and ask for your approval. Terraform must store the state of your managed infrastructure and configuration. This state is used for mapping real-world resources with your configuration, fetching the metadata, and also improving the performance of your large infrastructure. The state by default is stored locally under the name of terraform.tf state, but it can also be stored in a remote location, which works better in a team environment. Terraform will use this local state to create a plan before making any changes. Prior to any operation, Terraform does a refresh to update this state file to match the real world resources. The primary purpose of Terraform is to store the binding between the objects into a remote system and resource instances declared in your configuration. When Terraform creates a remote object in response to a change in the configuration, it will record the identity of that remote object against a particular resource object and then potentially update or delete that resource in response to your future update or changes in the configuration. At last, when you have no use for that infrastructure, instead of leaving them running, which may cost you money, you can choose to delete those resources. But instead of chasing all the resources which you have deployed in AWS console, you can directly do that using a single Terraform command. Terraform destroy uses the TF file to track those resources which were deployed earlier and then destroys the infrastructure. I hope this video gave you enough confidence to try Terraform yourself. So please use Terraform for infrastructure deployment and let me know, did you find Terraform easy or complex to use? You can consider subscribing to this channel, as this really motivates me in creating more content which is informative, just like this video. You can also follow me on Twitter, where I post updates related to my future videos. I'll see you in the next video. Till then, stay safe and keep learning.